Morning, everyone. How's everyone doing? Don't worry, can't hear you anyway. We're going to do grade 8, unit 7, lesson 8, right here. If you haven't gotten that out already, go ahead and get that out from your binder. And by the title, you can see we're doing combining bases. At any time, if you need to pause this, obviously pause it. I can't tell if you're pausing or not pausing it, so do whatever you got to do to stay up to speed. If you need to slow it down, then obviously hit pause. But we're going to be combining bases. If you remember, if I had something like a 3 to the 4th power, that 3 is our base, and that is our exponent. Blah, blah, blah. So today we are going to be noticing situations that you can and cannot combine a base, and I'll let the lesson kind of uncover itself, just kind of like all the others have. But let's go ahead and do this one. It says evaluate 5 to the 3rd times 2 to the 3rd. So if you want, that means just solve it. Evaluate means solve. What's the answer going to be? So take a second. If you need to, hit pause. And then go ahead, get out your calculator if you don't have one already. Hit pause and get one. And then try solving that. So if you need to hit pause and solve it. Otherwise, 5 to the 3rd is 5 times 5 times 5. Well, 5 times 5 is 25. 25 times 5 is 125 times 2 to the 3rd, which is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So all that turns into 8. 125 times 8. Well, that's 100 times 8, which is 800. And 25 times 8, well, that's like 25 cents. That's like 8 quarters, which would be $2. So that's another 200. So our answer is 1,000. Now, problem 2 says evaluate 10 to the 3rd. Well, that's 10 times 10 times 10. Or we should start to recognize 10 to any power is a 1 with that many zeros. That's the exponent. Well, that means there's going to be 3 zeros. 1, 2, 3. And that's all it has to do, other than we might want to look carefully and say, is this just ironic? Is this a coincidence? That one equaled 1,000. 5 to the 3rd times 10 to the 3rd. 5 to the 3rd times 2 to the 3rd. And 10 to the 3rd also equaled 1,000. And if you look carefully here, you might see something very peculiar, which is pretty much the theme and moral of today's lesson. So let's go to activity 1 and let's fill out this table. So you might see, first off, let's read the instructions, because maybe there is one where it says we get to skip. The table contains products of expressions with different bases and the same exponent. Complete the table to see how we can rewrite them. Use the expanded column to work out how to combine the factors into a new base. So if we look at the warm-up problem, or at least the one they gave us, this is kind of like the warm-up problem. That's 5 times 5 times 5, 5 to the 3rd, I can see it, times 2 to the 3rd, it's right there. Well, if you remember multiplication, for example, 8 times 2 is the same as 2 times 8. And I can rearrange it in any order I want, and I still get 16, right? So 5 times 5 times 5 times 2 times 2 times 2, they went ahead and rearranged it and said 5 times 2, or better yet, 2 times 5, times 2 times 5, times 2 times 5. You can see it there, there, and there. Well, 2 times 5 is 10, 2 times 5 is 10, 2 times 5 is 10. Well, 10 times 10 times 10 is nothing other than 10 to the 3rd. So if we look at the next one, they gave us the answer. What is 3 to the second times 7 to the second? It's 21 to the second. And there's a reason why we can just multiply the bases, but this only works if the exponents are the same. If the exponents are the same, you won't get a matchup quite right, and you no longer have that trick available to you. So this one, it says the expanded form would be 3 times 3 times 7 times 7. And now I can rearrange that as 3 times 7 times 3 times 7, which is 21 times 21. And lo and behold, anything times itself would be 21 squared. Now, I'll let you do the next one on your own. You can hit pause if you need to, but I'm going to jump down to 30. Now, I'm not going to do all of these for you for a reason. Some of these I'm going to have you fill out. You're going to try it on your own as long as you show that you got the work done. Right or wrong, I'll give you credit for it, but I don't necessarily want you just fast forwarding this and hitting pause and then writing stuff down, because it helps to listen to the explanations. So let's look at this one right here. 30 to the fourth. There probably is more than one way to get 30 to the fourth. So a lot of people could have a different answer. But what we're learning here is the 30 comes from two bases, a base and a base. Something times something's got to be that. And we probably should see it's going to be to the fourth power. So what times what is 30? Well, you could choose 1 and 30. You could choose 2 and 15. You could choose 3 and 10. You could choose 5 and 6. You could choose 6 and 5. But for the heck of it, let's just pick one. You can choose something else if you want. But let's do 5 times 6. And if we did that just right, then we need it to be to the fourth power. 5 to the fourth times 6 to the fourth. Well, now if I expanded that, that's going to be 5 times 5 times 5 times 5 times 6 times 6 times 6 times 6. And that's going to be 5 times 6 times 5 times 6 times 5 times 6 times 5 times 6. So that is 30. 5 times 6, 30 times 30 times 30, which is 30 times 30 times 30 times 4. 30 is 30 to the fourth power. Now again, you could have done that with, we could have switched this out and made it 3 and 10 if we wanted to, but don't do that if you already wrote what I did. In which case it would have been 3 times 10 times 3 times 10 times 3 times 10 times 3 times 10. Doesn't matter. You can see a lot of ways to go about this. So, why don't you hit pause and then try some of these on your own, and then we'll see what you come up with, and we'll check your answers. Let's see here. See how you did. Let's look at this a to the n times b to the n. Well, it's expanded form. There's not really anything to write because we don't really know. That's going to be, right? Who knows what the expanded form goes here, because we don't know how many times we have to write it, do we? We should know, though, that that's going to be, our exponent should be, whatever it is, it's going to be a times b. We can just write AB. That means multiply. If you wrote a times sign, great, no big deal. That's going to be AB. Now here's where you have to be very careful. I have to. If I don't, this would be wrong. I have to put this in parentheses, and now I can put it into the nth power. Otherwise, AB to the nth power, if I wrote AB to the nth, that's just saying I want B to the nth power, not A to the nth power. So I have to put it in parentheses because I want A and B both to be to the nth power. Because we've just learned that you take the bases, you can multiply them, and then keep the exponent the same. Whoa. You gotta multiply the bases, and the exponent can be the same. That's a shortcut for figuring out something like that. And how about this one above it? Well, you could write 2 to the fourth, 2 times 2 times 2 times 2, and x to the fourth, x times x times x times x. And that's going to be, go ahead and make sure you write that out, 2x, again, in parentheses, to the fourth power. You got to have those parentheses. We didn't need parentheses above because 30 to the fourth, there's no, it's just 30. I mean, 15 to the third, that's just that. And this last one, what do you think? 7 times 7 times 7 times 7, 7 to the fourth times 2 to the fourth times 5 to the fourth. Well, you can write it all out, but that's going to be 70 to the fourth power. Kind of blended it in there. And you can see that would be 7 times 2 times 5 times 7 times 2 times 5 times 7 times 2 times 5 times 7. You could rewrite that, and that'd just be 70, 470s, so to speak. Now, the last one says, can you write problem 2? Is there another problem? No. Can you write 2 to the third times 3 to the fourth with a single exponent? What happens if neither the exponents nor the bases are the same? Well, the only way we could possibly do this, if the bases aren't the same, because this would be 2 times 2 times 2 times 3 times 3 times 3 times 3, you could kind of maybe try to do that, because you could take these 3 and these 3, but then we have an odd man out here. No pun intended, it's the number 3, it's odd, get it? So there's kind of lots of ways that you could answer this. I don't think there's a right or wrong as long as you have a good explanation, because you could possibly write it with a single exponent as long as you multiply something times 3 at the end. But then I guess it wouldn't have a single exponent because 3 technically has an exponent, 3 to the first. So I'll leave it up to you what you think. You could easily argue that no, it doesn't. It says, can you write it with it? You could say no, because there would technically be 2 exponents, because it would be 6 to the third times 3, which is technically 2. So I'll leave it up to you what you want to write there. But otherwise, 808, 882, we got a shortened day. That might be enough time. If not, where are we at? I should have already had this up here. If we look at some of these practice problems, lesson 8, select all the true statements. Is 2 to the 8th times 2 to the 9th, is that 2 to the 17th? Probably. Is 8 squared times 9 squared 72 squared? I don't know. This is getting, remember, what did we just learn? If the bases are the same and the exponent, or sorry, if the bases are different and the exponents are the same, then I guess B might be true. C, did we just learn that, well, it can't be B and C, so one of those is right or one of those is wrong. And the last one's 2 to the 8th times 2 to the 9th. How does that work if we already said A is true? How could it go to 4 to the 17th? That would be 17 twos, not 17 fours. So find x, y, and z of 3 to the 5th. 3 times 5 to the 4th times 2 times 3 to the 5th times 2 times 5 times 7. This one's kind of cool. You just have to figure out how many 2's are there, how many 3's are going to be, and how many 5's are there going to be. Well, I can see there's going to be 4 3's here and 5 3's here. That's going to be 9 3's, or 3 to the 9th. I can see there's going to be 4 5's, sorry, and 7. That's 4 and 7 make 11. And the 2's, 2 to the 5th, that's 5 2's. 2 to the 7th, that's 12 2's. So 2's obviously go there. 3, that goes there. And 5, that 11 goes right there. A lot going on. I think we're probably good for today. I don't know, maybe you have enough time. You could try, if you have time, do problem 3. Otherwise, let's call it it. It's a shortened Friday, so we're going to call it good. Not going to assign any homework this weekend. Hope all is well. Just email me. You can email me. I still am available by email. So if you have questions or concerns, just let me know. Other than that, let me figure out how to stop this recording. There it is. Have a great weekend. Peace.